Have you ever looked at an IP address and just thought, what on earth am I looking at? It feels like a secret code, right? Well, today we're going to crack that code. We're going to solve a fun little puzzle together and make sense of it all.
All right, let's jump right in. Here's our challenge for today. We've got this list of IP addresses, and you'll notice each one has that slash and a number at the end. Our job? To figure out where each one belongs. Are they subnet addresses, host addresses, or broadcast addresses? Let's sort them out.
Okay, I get it. Right now, this probably looks like a total mess. But trust me, there's a super simple logic behind all of this. It's like one of those magic eye puzzles. Once you see the pattern, you'll never be able to unsee it. Okay, first things first, let's nail down what we're talking about. What is a subnet address? Simple. It's always the very first address in a range. A great way to think about it is like a street name. Main Street doesn't point to one specific house, right? It refers to the entire street. That's your subnet address. And on the flip side, we have the broadcast address. As you might guess, it's the total opposite. It's the very last address in that block. Sticking with our street analogy, this is like the town crier shouting a message for everyone on Main Street to hear. You send one packet to the broadcast address, and every single device on that network gets it. So we've got the first address and the last address covered. What about everything in between? Well, that's where the host addresses live. These are the usable assignable addresses. They're like the actual house numbers, 101 Main Street, 102 Main Street. They get assigned to your laptop, your phone, your gaming console, basically anything that needs to connect.
And that right there, that's the whole secret. It's the golden rule for this entire puzzle. Let's say it one more time because it's so important. The first address is the subnet. The last is the broadcast, and everything in between is a host. If you remember that, you're pretty much all the way there.
But wait a second, how do we know what the first and last addresses even are? That's where that little slash number comes in, that /27 you see. That's the real magic key here. It's called CIDR notation, and it's basically our secret decoder ring that tells us exactly how big our street or our block of addresses is. So, how do we use it? It's just a bit of simple math, I promise. Every IPv4 address is made of 32 bits. All you do is take that 32 and subtract the slash number. So for /27, we do 32 minus 27. That gives us 5. Now, for the final step, we just calculate 2 to the power of that number. So 2 to the power of 5 is 32. And boom, that's our block size. This network has a block of 32 addresses. Okay, so our block size is 32. What does that mean for our subnet addresses? It means the starting points of each block, the street names, have to be multiples of 32. So you'll have a subnet starting at 0, the next one at 32, the one after that at 64, then 96, you just keep adding 32. And take a look at our address, 192.168.232. That lands exactly on one of our starting points. So what does that make it? Yep, it's a subnet address. See, the puzzle is already starting to solve itself.
All right, let's grab the next one. Now look closely here. The IP address part is exactly the same. 192.168.2.32. But the slash number, that's changed to /26. And believe me, that one little number changes the entire game.
We're just going to rinse and repeat the same formula. We take 32, subtract our new slash number, 26, and that leaves us with 6. Then we do 2 to the power of 6, which gives us 64. So our block size is now 64 addresses. And notice that, right? The slash number went down a little, but the block size got bigger. So if our block size is 64, our subnet starting points are going to be multiples of 64. We're talking 0, then 64, then 128, and so on. Now, let's look at our address again. It's .32. Does that land on one of those starting points? Not even close.
Okay, so we know it's not a subnet address. The block it's in starts at 0. And since the block size is 64, the last address, the broadcast address, would be .63. Our address, 32, is right smack in the middle of that range. So what does our golden rule say? If it's in between, it's a host address. Perfect.
Okay, we've got the tools, we've got the secret code. Let's go back to that original list of addresses. I bet this looks a whole lot different now, doesn't it? It's not so scary when you know how to break it down. And here we are, the solved puzzle. See how everything just snaps into place? You can apply that same exact logic to every single one. Take the /22, for example. That's a huge block of 1,024 addresses. And 192.168.12.0 is a multiple of that, so it's a subnet. Or look at the /25. That gives us a block of 128. The address 192.168.4.127 is the very last one in its block, so that's a broadcast. It just works. Now, to make your life even easier going forward, I want to give you something to stick in your back pocket. Think of it as a handy little cheat sheet for your networking toolkit. This table is awesome. It just lays out the most common slash notations you're going to see. It tells you the total addresses in the block and, maybe even more useful, how many actual usable host addresses you get. And always remember why that number is 2 less than the total, right? You always lose 1 for the subnet address and 1 for the broadcast.
And there you go. You've officially cracked the IP address code. The big takeaway here is that little slash number isn't just some random detail, it is everything. It's the key that tells you the size, the start, and the end of any network. So now that you can read subnets like a pro, what's the next big network mystery you want to solve?